Okay, so let us begin with the number system first. In the number system, the first thing which you need to understand is natural number. So some of them already know that. Natural number means counting numbers are called natural numbers. So when you count something, you start with 1, 2, 3, 4, 5. You can also call them positive whole numbers, or you can simply say counting numbers are called natural numbers. In mathematics, we denote natural numbers by capital letter N. Next is integers. So what are integers? Integers are positive or negative whole numbers, including 0, such as -3, -2, -1, 0, 1, 2, 3, and so on. Integers are denoted by capital Z in mathematics. Next, you have even numbers. Even numbers means multiples of 2. Multiples of 2 means 2, 4, 6, 8, 10, and so on. So the table which you did in other classes, like 2 by 1 is 2, 2 by 2 is 4. These are called multiples of 2. And similarly for 3, multiples of 3 are 3, 6, 9, 12, and so on. But even numbers are those numbers which are multiples of 2. Then you have odd numbers. Odd numbers means which are not multiples of 2. For example, 1, 3, 5, 7, 9, and so on. Next is prime numbers. So what are prime numbers? Prime numbers are those numbers which has exactly 2 factors, 1 and the number itself. For example, the smallest prime number is 2 because 2 has only 2 factors, 1 and number itself, which means 2. 3, 5, 7, and then 11, 13. These are all prime numbers. For example, 9 is not a prime number. Why? Because 1 is a factor of 9, 3 is a factor of 9, and 9 is a factor of 9 as well. So there are 3 factors. So it does not satisfy the condition of prime numbers, which means it has to be a 2 factor. For example, 1 is not a prime number as well because 1 has only 1 factor, which is 1. So that's why 1 is not a prime number. So smallest prime number is 2. And 2 is the only even number which is a prime number. Why? Because all other even numbers are basically multiples of 2. So for example, 4, 6, 8. These numbers are all 2 is a factor of these numbers as well. So that's why they cannot be considered as a prime number. So 2 is the smallest prime number, even number, which is a prime number as well. Now, it looks like some people wants to join here. I don't know if they. Okay. Tracy is not here. Okay. Prime numbers, and the next type number is rational numbers, which is very important. So what are rational numbers? Rational numbers are those numbers which can be expressed as a fraction, something like P over Q. But there's a catch here. P and Q both must be an integer, which means the top number and the bottom number must be an integer. For example, 2 over 3 is a rational number. 5 over 7 is a rational number. Minus 3 over 10 is a rational number. Why they are rational numbers? Because the top number and the bottom number both are integers. They are all integers. Okay, What are integers? We already discussed. Negative, positive whole numbers, including 0. These are integers. So even if you write, let's say 5, I can write down 5 as 5 over 1. So it can be considered as a rational number as well. So what are irrational number? Irrational numbers means which cannot be expressed as a fraction. For example, root 3 over 2. Now the bottom number is an integer, which is 2, but the top number, root 3, is not an integer, isn't it? Square root of 3 is 1.732, and then it gives you some random numbers if you use calculator. So it's not a whole number, it's not an integer, so that's why these are called irrational numbers. Okay, so another important part here is, let's say 1.5. It's a common mistake now. Maybe some of you understand or some of you get confused with this. So 1.5, if I ask you if it is a rational number or irrational number, let's see what's your answer. Can you guess 1.5 as a rational number or irrational number? Can you guess? $1.5, is it a rational number or irrational number? Can you answer in the chat? Okay, rational. I got one answer. Anybody else? Okay, somebody's saying irrational. I was expecting. Okay. Okay, two people saying irrational. That's why I ask you this question, because you need to understand the concept. First of all, if the number is written in decimal form, it doesn't mean that you can straight away say it's an irrational number or rational number. So how to check that? First of all, you need to check that can I express this as a fraction or not. For example, 1.5 can be written as 3 over 2, isn't it? So if 1.5 can be written as 3 over 2 and 3 is an integer, 2 is an integer, so it should be a rational number. So rational number is the correct answer. Okay. So even if you write 1.573, it's a rational number because I can write down this as 1573 over 1000. Like this. 1573 over 1000 is 1.573. So if you see some number written in decimal form, that doesn't mean it's irrational or rational number until unless you make sure whether you can express as a fraction or not. Okay. But why root 3 is irrational? And the reason for that is if you use your calculator, you will get answer something like this. And it is never ending because the numbers or the decimal places are not repeating. So I cannot express this as a fraction because I don't know where it is ending, isn't it? So I cannot express this as a fraction. So that's why these kind of numbers are called irrational numbers. Doesn't matter you write like in decimal form or you like in Cert form, which is basically called Cert form, root 3. Another example is, let's say 1.777777. So 7 is recurring. So can you guess whether it is rational or irrational now? Let's see. Somebody is saying irrational. Anybody else? Irrational. Irrational. Okay. So pretty much everybody is saying irrational. It is actually rational number. Okay. So how will you express this as a fraction? And you did this type of question in your other class, in the previous classes. So I will say, let's say x is the value of this. Okay, so this is recurring. And what you need to do is you need to multiply both sides by 10. And the reason for multiplication by 10 is because only one decimal place is repeating. Okay, 7777. Only 7 is repeating. So that's why it's 10. If you have two numbers repeating, like let's say 78787878 after the decimal, so you multiply by 100. But let's do this first. So if you multiply by 10, you will get 10x equals to 17.77777 and so on, isn't it? And what you do is now you subtract these two. So 10x minus x will give you, so I'll write down here maybe for convenience. Okay, so if you subtract now, what will happen is 10x minus x will give you 9x, and 17.777 and 1.777. So what will happen? These all these sevens will cancel, and 17 minus 1 will give you 16. So x is equal to 16 divided by 9. So 16 is an integer or whole number. 9 is a whole number. So it's a rational number. Okay. So do you understand this? Okay. So some number with a recurring decimal is a rational number, not an irrational number. So one thing you should clear in your mind, that if the number is written in a decimal format, that doesn't mean that it's an irrational number. Okay, you need to check whether it is recurring, whether it is not repeating. So for example, there are two types of numbers. If I write 1.72, it's rational because I can express this type of number as a fraction like this. And if some numbers has a recurring decimal like 787878, these are also rational numbers because I can express as a fraction. Okay, so both of these numbers are rational numbers. These are the two types. But if you have a number, okay, with a random decimal places, for example 728 150 123, so nothing is repeating or nothing is kind of recurring, isn't it? So these are definitely irrational number. So if you have a number like this, you need to check whether there are like limited decimal places, or if there are multiple decimal places, you have to make sure whether it is recurring or not. Okay, so that is the idea behind irrational number and rational number. One of the best example of irrational number is pi. Pi is 3.14 something. Although we write this as 22/7, but this is just an approximate value. Okay, so you cannot call this as a rational number. So 3.14, and these numbers are repeating. These numbers are randomly coming, so you cannot express as a fraction. So pi is the example of irrational number. Okay, now next thing is pretty much simple, real numbers. So real numbers are denoted by R, and this covers all numbers between -infinity to +infinity. Doesn't matter whether they are natural number, integer, or irrational number, rational number, everything is comes under real number. Okay, now that's all about the number system. Next thing which you need to study is, let's say, factors. So what do you mean by factors? We say 2 is a factor of 8, isn't it? 2 is a factor of 8. Why? Because 2 goes into 8. So 8, if you divide by 2, you will get 0 remainder, isn't it? That's why we say 2 is a factor of 8. And this property is very important, which we will be using later in the algebraic expression. So there are word problems which are based on this. So if the remainder is 0 and you get a whole number here, you can call that as a factor. Okay, and we already covered multiples. Now there are two important things which we use in algebra. One is called highest common factor. One is called lowest common multiple. HCF LCM. So let us understand the first one, highest common factor. So what do you mean by highest common factor? So highest common factor. So let us start with factors first. If I give you a number, let's say 15 and 5, and if I ask you what is the highest common factor, you will say yes, it is 5, isn't it? Because the numbers are small, so you can quickly get it. But if the numbers are big, something like 45 or 60 or maybe bigger than that, let's say 75 or 165 or 125, something like that, then sometimes it is very hard to get the factors quickly. So how will you get the highest common factor for any number, any two numbers, let's say, um, without using any hit and trial method or something in your calculator, let's say? And it itself a question, like they can ask you what is the highest common factor of, let's say, 45 and 60. So you need to understand this table in order to get the factors of 45 and 60, let's say. So how to get the prime, basically factors of this? So you start with any prime number which goes into
Hello.
45. Hello?
Uh,
Hello? Yeah?
do you know, would you please name out the factors that go into 45?
Sorry?
What are the factors that go into 45?
Yeah, we are going to find out now.
Yeah, right. Thanks.
Yeah. So that's the idea. We need to find out the factors of 45 and 60, and then from the factors we need to find out the highest common factor. So this is a method which we need to use. And how to start with this method? So you need to start with the prime number which goes into 45. Okay, so it doesn't, order doesn't matter. You can choose any prime number you want. For example, I choose 5. 5 multiplied by 9 is 45. Okay, and now 9 goes into 3. So 3 by 3 is 9, and 3 by 1 is 3. So if you multiply basically these three factors here, 5 by 3 by 3, you should get 45. So this is how we find out the factors of 45, which you can write down as 5 by 3 by 3. 5 by 3 is 15, and 15 multiplied by 3 is 45 again. Okay, so this is how, and these are called prime factors of 45. Why we call prime factors? Because they are all prime numbers. 3 is a prime number, 5 is a prime number. Okay, you need to find out the prime factors in order to get the highest common factor. For example, I cannot use 15 here instead of 5 because 15 is not a prime number. Okay, so let's find out the prime factors of 60 now. So I can start from 2, let's say. So 2 by 30 is 60. 2 by 15 is 30. And then 15, I can use 3 here. So 3 by 5 is 15. And 5 by 1 is 5. So you need to work out until you get 1. And now, again, 60 can be written as 2 by 2 by 3 by 5. And in order to check that, you can see 2 by 2 is 4. 4 by 3 is 12. And 12 by 5 is 60. So it means your answer is correct. So this is the way you can find out the prime factors of any number you want. Okay. Now I am interested in finding the highest common factor. So first, what are the common factors? You can see that 3 is common and 5 is common. So I'll write down here 3 is common, 5 is common. And what is 3 multiplied by 5? 15. 15 is your highest common factor. 3 is a common factor, 5 is a common factor, but you multiply 3 by 5, you will get 15. That will give you the highest common factor straight away. Okay, let's take another example quickly. 75 and 90. I want to find out the highest common factor of these two. So first I will find out the factors. So 75. Let's start with 5. So 5 by, sorry, 15. Okay, then 5 by 3, and then 3 by 1. So 75 can be written as 5 by 5 by 3. Let's start with the 90. So when you have 90, okay, and what's the first is digit here? 0. If the digit is 0, that number is divisible by 2 and 5 as well as 10. Okay, but anyways, we can't use 10 because 10 is not a prime number, but I can use 2 or 5. So let us use 2. So 2 by 45 will give you 90, and then I can use 5. 5 by 9 is 45. Then I can use 3. 3 by 3 is 9, and 3 by 1 is 3. Okay, so what we are getting here, 2 by 5 by 3 by 3. And you can check that 5 by 5 is 25, 25 by 3 is 75, and then 2 by 5 is 10, and 10 by 3 30, 30 by 3 is 90. So your answer is correct. So what are the common factors? 3 is common, 5 is common. Okay, that's it. So 5 is common, 3 is common. So again, highest common factor of these two numbers is equals to 15. Okay, is that clear? Does it make a difference whether you use 5 or 2? No, there's no difference. Order doesn't matter. You can start with 2 or you can start with 5. It will automatically give you an opportunity to include 2 at the later stage. Okay, but it has to be a prime number. You cannot use any other number when you're doing factorization. Okay. Okay, so I hope highest common factors and how to do prime factorization is clear to you. Now I'll take the same example, but in order to find out LCM. So LCM is lowest common multiple. First of all, let's understand what do you mean by lowest common multiple. So if I want to find out, let's take a simple number, again 45 and 60, let's say, and let's use right to left. So first word is multiple. So what are the multiples of 45? 45 by 1 is 45. 45 by 2 will give you 90, 135, 180, 225, okay, 270, 315, 360. So these are multiples of 45. 60 by 160, 120, 180, 240, 300, 360. Okay, you don't need to make any notes because the video will be available to you, so just focus on what we are doing. Okay, first word was multiple. These are multiples of 45, these are multiples of 60. Okay, what's the second word? Common. So what are common multiples? 180, 180, 360, 360. Then the third word is lowest. So what's the lowest common multiple then? 180. Obviously, you don't need to do this. This is just to explain you what is the meaning of lowest common multiple. Okay, a lot of students don't even know that what they're doing. So lowest common multiples means 180 is the multiple, 180 is the common multiple, and 180 is the lowest common multiple between 45 and 60, let's say. Okay, but how to get it straight away without doing all this? You don't need to use any separate method. We already got the factors of 45 and 60 in our previous workings. So let's go back here. 45 is 5 by 3 by 3. 5 by 3 by 3. And 60 is 2, 2, 3, 5. 2, 2, 3, 5. So you already know how to get the prime factors. How to get the LCM now? So again, you check what is common. So you can see 5 and 5, 3 and 3 is common. So write down here 5 and 3. Obviously this is your highest common factor, but for LCM you need to do one extra step. So write down the 5 and 3 which are common, and then write down the single ones as well. So what are the single ones left? 2, 2, 3. So 2, 2, 3, and then multiply. So 5 by 3, 15, 15 by 2, 30, 30 by 2, 60, and 60 by 3, 180. And that was your answer here. Okay, so the LCM of 45 and 60 is equal to 180. Okay. Okay, I'll give you one question and hope everybody has a notebook there. And the question is, I want to find out number 1, prime factors of these two numbers. Okay, so find out prime factors. Number 2, highest common factor. Number 3, lowest common multiple. Can you do it quickly and send me the answer? 90 and 120. And I can show you this example just for reference if you want. Okay, very good. So these are your prime factors, 2, 5, 3, 3. Okay, 2, 5, 3, 3. 2, 5 is a 10, 10 by 3, 30. Very good. And 120, 2, 2, 4, 12. Yeah, looks okay. Highest common factor is 30. So what is common? 5 is common, 2 is common, 3 is common. Very good, that's correct. Highest common factor is 30. And what's the LCM, Benjamin? So for 90 we already did it here. Okay, 2533. So you already have it. So you just have to find out for 120. Okay, so 120, 60, 30, 15, 5, and then 5 ones are 5. Okay, so 120 is 2 by 2 by 2 by 3 by 5. So it doesn't matter, order doesn't matter. Make sure the factors are correct and you're using prime numbers. So that's exactly same as what Benjamin got. And for 90 it's 2533. So 2533. Okay, first you need to check what is common. So 3 is common. Okay, and 5 is common. And this is and 2 is common. Okay, so this is your highest common factor, which is 30. Now 352, write down this again, and then write down the single ones. So single one means 2, 2, and 3. So 3 by 5, 15, 15 by 2, 30, 30 by 2, 60, 60 by 2, 120, 120 by 3, 360. Yes, that's correct. Okay, yeah, so everybody got 360 as the answer. Okay, so this is very important to understand how to get the LCM and that serves, because now you'll be doing fractions. Okay, so how to, you already know what do you mean by fraction. Fraction means the rational numbers, so something over something. But the question is how to add them, how to subtract them, how to multiply them, and how to divide them. So the most important part is how to add and subtract two fractions. So I'll take simple example. Let's say 5 over 7 and 3 over 14. Okay, these are two simple fractions. Now, in different schools and different classes, they explain different way, but the proper way of doing it is you have to get the LCM. Okay, so 7 and 14, you already know how to get the LCM, but for when you're solving fractions, let's say, there are some quicker way of finding the LCM. So for example, in the denominator, I have 7 and 14, and I want to get the LCM of these two. Okay, since 7 is a factor of 14, I can directly use 14 as my LCM, the bigger number as my LCM. Okay, although you can find out if you don't know. For example, if you find the factors of 14, so 2 by 7, 14, 7 by 1. So you will say 14 is 2 by 7, and 7 is obviously 7, because, or you can write down 7 as 7 by 1, doesn't matter. So the common factor is 7, but I want to find out the LCM, so I will say 7 by 2, okay, which will give you 14. But you don't need to do this when you're solving the fractions. There are a couple of things which you need to understand in order to get the LCM quickly. 7 is a factor of 14, so choose bigger number as your LCM. So write down 14 here. Okay. Now, what's the next step? After getting the LCM, you divide 14 by this number here, 7. So 14 divided by 7 is 2. So you multiply 2 on the top. Copy plus sign as it is. Now 14 divided by 14 is 1. So you just multiply 1 on the top. That's the idea. And it's the same process for any type of fractions. Okay. So once you get the LCM, 5 by 2 is 10, 3 by 1 is 3. So answer is 13 over 14. Okay. That's one type of, let's say, fractions. Let's take another example. 7 over 5, 3 over 4. 5 and 4. They are not factors of each other, and there is no factor common between them. So in order to get the LCM, you simply multiply them. So 5 by 4 will give you 20. So directly you can get the LCM like this. Okay. But the process is same as I said in the previous question. 20 divided by 5 is 4. So you multiply 4 on the top. 20 divided by 4 is 5. So you multiply 5 on the top like this. Okay. 28, 15 over 20. So what you will get, 28 plus 15 is 43 over 20. Let's take another example. 7 over 45 plus 11 over 60. Now you have big numbers. Okay. I can give you some example I'm not sure about your class, but in many classes I have seen what they say to the student is multiply this with this, this with that, and this with that. Okay, that's not a proper way of doing it. Okay, and you will end up with very big numbers, as well as you will waste your time in the exam if you follow this kind of silly tricks. Okay, so what's the process? So the process is find out the LCM. So LCM of 45 and 60 we already got it from our previous examples, which was 180. So you put 180 here. What's the next step? 180 divided by 45 will give you 4, isn't it? So 7 by 4 on the top, and 180 divided by 60 will give you 3. 11 by 3. 7 4 is 28. 33 over 180, and this will give you the answer. Okay, so that's the proper way of doing it. So 45 and 60, I cannot get directly the LCM, because although 45 is not a factor of 60, but they have some common factors. For example, 5 is a common factor of 45 and 60, because you know that, okay, 45 and 60 both are divisible by 5. You also know maybe 15. So that's why when there are factors common between these two numbers, let's say, you need to follow the proper way of finding the LCM. There is no short tricks for that. Okay. However, if you have, let's say, two numbers in the denominator and they are not factors of each other, they don't have anything common, then you simply multiply them 5 by 7, which will give you 35. That will be the LCM. Second option is if you have, let's say, 5 in the denominator and let's say 25 in the denominator. So 5 and 25, you know that 5 is a factor of 25. So straight away you can choose the bigger number as your LCM without doing anything. Okay. So that is the idea of solving the fraction. Now it's the same thing in case of addition or subtraction, because you have to follow the same process, just change the sign. Instead of plus, you have to use minus sign. Okay. Now next is algebraic expression. So there are multiple algebraic expression. First of all, what do you mean by algebraic expression? So algebraic expression is a combination of mathematical operations. For example, plus, minus, multiplication, and division. These are called mathematical operations. And it contains variables. For example, it can have x, it can have x squared, or it can have x or y, something like this. So these are called variables in mathematics. Okay. So algebraic expression is a combination of this. So if I write x plus y equals to 10, okay, this is called algebraic equation. But if I simply say x plus y, it's an algebraic expression. Okay, so if you put an equal to sign, it becomes algebraic equation. Now x plus y, this is called linear expression. Why it is linear? Because the highest power of x and y is 1, or the highest power of the expression is 1. If I say x squared plus 2x plus, let's say, 10, it's called quadratic expression because the highest power is 2. If I say x cubed plus 5x squared plus 3x plus 10, it becomes cubic. So the highest power is 3 here. Okay. So depending on the power, you can say whether it is linear, quadratic, and cubic, depending on that. Okay. Now, you know how to add or subtract two fractions. So let's take an example from your exam paper. So 5 minus x over 5 plus x minus 4 over 4. So we are trying now some exam paper questions now. So you can see that these are two fractions. So first thing is I need to take the LCM. 5 and 4, they have they don't have anything common. So 5 by 4 is 20. That would be your LCM. And then the same process, 20 divided by 5 is 4. So you multiply 4 on the top, but use bracket because you have multiple expression there. And then 20 divided by 4 is 5. So you will get 5 multiplied by x minus 4. Now how to multiply a number inside the bracket? You have to multiply number with each term inside the bracket, isn't it? So 4 by 5 is 20 minus 4 by x is 4x plus 5x, and 5 multiplied by minus 4 is minus 20. So make sure you multiply signs as well. So that's plus sign, plus multiplied by minus is minus over 20. And then you just simplify. 20 minus 20 is 0. 5x minus 4x is x. So x over 20. Okay. So that's the use of LCM. If you know how to find out the LCM, you can use to solve these kind of questions. Okay. So let's take the next type of example in algebra. What about if I want to multiply okay, sorry. Okay, what if I want to multiply two brackets 6x minus 3 multiplied by 2x minus 1. Now you have two brackets. So how to multiply? So write down the terms of the first bracket 6x minus 3 like this, and multiply both of them by the second bracket just to make it simple. So what I'm doing, I'm writing terms of the first bracket and multiplying both of them by the second bracket. And now you know how to multiply with one bracket. So 6x multiplied by 2x and then 6x multiplied by minus 1. So 6x multiplied by 2x will give you 12x square. 6x multiplied by minus 1 will give you minus 6x. Same thing here. Minus 3 multiplied by 2x will give you minus 6x. And now you have to be careful. Minus 3 multiplied by minus 1 is plus 3. That's very common mistake. Student forget to multiply by the negative sign, which is outside the brackets. You have to consider that. So after that, you just have to do one more step. So 12x square minus 6x minus 6x is minus 12x plus 3. So this is how you can multiply two brackets. Okay. Is there any question? Everybody's okay? Or is there any question? Okay. So the next question is pretty much similar, but I need to multiply x plus 5 by x squared minus 2x plus 6. So what's the difference between this question and previous question? There's no big difference. Both have two brackets, but in the second bracket you have three terms. Doesn't matter. So the terms of the first bracket, x and plus 5, and you have to multiply by the second bracket. Now some people use box method, but box method is unnecessarily complicated. Too much work required. This is simple. You just have to write down the terms of the first bracket and multiply by the second bracket, and you know how to multiply with one bracket. Now x with x square, and then minus 2x, and then 6, step by step. X by x square is x cube. X by minus 2x is minus 2x square plus 6x, and then you solve this as well. So 5x square, 10x plus 30. Okay, 5 by x square, 5 by minus 2x, and 5 by 6. And then you just solve the like terms. X cube minus 2x square plus 5x square will give you plus 3x square. We always use the sign of the bigger number. So minus 2x square plus 5x square is plus 3x square. 6x minus 10x minus 10x is minus 4x, and then you're left with plus 30. So that's the answer. Okay, so I hope you understand how to multiply two brackets. There's another question. So these are all your exam type question I'm doing, okay, step by step, because I don't want to jump into step by step. You need to understand the algebra, and algebra is everywhere in your mathematics. So if you're not good at algebra, you will be struggling in other chapter as well. So the question here is, which is same as what we did earlier. They are asking you to convert this into a single fraction. So obviously there are two fractions here, and we want to reduce this to, or simplify to, single fraction, and which you can do it by taking the LCM. So again the same thing, but with little bit 3 by 4, 12. 3 by 4 is 12. That's the LCM, because 3 and 4, they are not factor of each other, and there is no common factor. Same thing again, 12 divided by 3 is 4. So you multiply 4 to the top part here, minus, keep minus as it is. 12 divided by 4 is 3. So you multiply 3 to this. Okay, exactly the same thing. The only thing is you have minus in between the two fractions. Then open the bracket, 4x plus 4 by 2, 8. And then you multiply by this as well. So careful about the negative sign. Minus 3x and plus 9 over 12. 4x minus 3x is x. 8 plus 9 is 17 over 12. So that's the answer for this question. Okay, so I hope now you are quite okay with the fractions stuff. Now the next question from your exam papers is, first part of this question is multiply out and simplify what? X plus 5 whole square. So they are saying multiply out and simplify. So x plus 5 whole square means what? X plus 5 times x plus 5. Square means you multiply the number by itself. Okay, so it's the same way how you multiply two brackets. So x plus 5, these are the terms of the first bracket, and you need to multiply by the second bracket. Obviously the second bracket is same as the first one, so but follow the same process. X square plus 5x plus 5x plus 5 by 5 is 25. So final answer is x square plus 10x plus 25. Okay, that's the first part of the question. Second part of this question is, hence or otherwise show that this expression x plus 5 whole square minus x minus 5 whole square is always divisible by 4. You need to prove that answer for this question is always divisible by 4. Forget about that at the moment, just simplify first. Okay, and they said hence or otherwise. It means the solution of this is related to the previous answer. So I already know that x plus 5 whole square is x square plus 10x plus 25. So you don't need to do it again, okay? Because both questions are part of the same question. However, this is x minus 5 whole square. Now one way is you can do it separately if you want, but it will only change plus 10x to minus 10x. Okay, so I can quickly do it here just for your reference. So x minus 5 whole square is equal to x minus 5 times x minus 5. Okay, so exactly the same way how we did the previous thing. Okay, so this is how you can find out x minus 5 whole square. Now you have to be careful with the bracket and this minus sign. So first you open the first bracket, obviously it will give you the same thing back, but when you open the second bracket, outside the bracket you have a negative sign, and if you have a negative sign you can consider this as, let's say, minus 1, isn't it? So generally when we open the bracket we multiply everything by whatever is outside the bracket. So this time you have to multiply by negative sign, and what will happen? It will change the sign of these terms. Okay, so x square becomes minus x square, minus 10x becomes plus 10x, and plus 25 becomes minus 25, and then you just simplify. So x square minus x square gone, 25 minus 25 is 0, 10x plus 10x is 20x. Okay, and this is always divisible by 4 because 20 is divisible by 4. Now why they are saying always divisible by 4? The meaning of always divisible by 4 means you have x here in your answer, so you can choose any value of x, isn't it? But always divisible by 4 means whatever you get with using x value, that answer will be divisible by 4 because you have 20, isn't it? So if you use 20 and x value as, let's say, 5, doesn't matter, but this will be divisible by 4 because 20 is divisible by 4. Okay, so this kind of questions they can ask you. Okay, now you know how to solve two fractions or add or subtract two fractions. They can give you equation, algebraic equation with two fraction, and they will say solve. Obviously whenever they give you some equation they will say solve. And what do you mean by solve? Solve means you need to find the value of the variable, whatever is the variable there. At the moment it's x, so this is called linear equation in one variable because you only have one variable x and the power of x is 1, and that's why it is called linear equation in one variable. Now question is how to solve this and how to get the answer for x. So since I can see here there are two fractions, so I don't need to worry about the 5 on the other side at the moment. I should focus on the fractions first and convert into single fraction. Okay, so let's focus on left hand side at the moment. 3 and 2, LCM would be 6, and 6 divided by 3 is 2, so I should multiply 2 to this term, minus 6 divided by 2 is 3, so I should multiply 3 to this term. Okay, so 2 by 2x is 4x plus 8 minus 15x plus 21, isn't it? Minus 3 multiplied by minus 7 is plus 21, minus 3 multiplied by 5x is minus 15x over 6 equals to 5. You have to keep on writing 5, do not forget to do that. Now let's simplify. 4x minus 15x will give you minus 11x. 21 plus 8, 29 over 6 equal to 5. So first step is to simplify the fractions. So you had two fractions, we simplified, and now we have one fraction. Once you get that, then you need to get rid of the fraction, which means 6 multiplied by 5, because 6 in the denominator. So if you move to the other side, you have to multiply. So 5 by 6 is 30. What's the next thing? I want to find out the x values, so I will move constant term to the other side. So it will change to minus 29, which will give me 1 here. And then this is minus 11x times x. So I need to divide both sides by minus 11. So answer for x is minus 1 over 11. So whenever they give you questions like this, where you have two fractions separated by plus or minus, you solve or simplify the fractions first, and then this is all manipulation which you need to do. Okay. Next thing is how to basically factorize a quadratic equation or expression, let's say. So let me see what example you have in the past paper. Yeah. So the question is 3x squared plus 11x minus 4 equals to 0. And we need to solve this. So 3x squared plus 11x minus 4. Idea is you need to multiply this term with this first. So minus 4 multiplied by 3 will give you minus 12. So first you need to multiply by this number. So constant term, which is minus 4, multiply by the coefficient of x squared, which is 3. And then you need to find out the factors of 12. So what are the factors of 12? You can say 4 by 3, isn't it? 6 by 2 or 12 by 1. And you need to choose a pair of factor or a group of factor, let's say, which will give you 11 by adding or by subtracting. So obviously 4 and 3 is not the right option. 6 and 2 is not the right option. 12 and 1. So 12 minus 1 will give you 11. This one, isn't it? So this is the right factor which you need to choose. Now what's the use of factor? So you write first term 3x squared. Yeah, you can use the bracket method as well. But the reason I'm explaining this, because if you get a big numbers, then some students struggle with that. So you just have to find out the factors and choose the right one, which will give you the middle term 12x minus 1x minus 4. So the first term and the last term will stay as it is, but 11x, which is the middle term, can be split into 12 minus 1 like this. Okay, so you have 4 terms now, and from the first 2 terms, sorry, from the first 2 terms, what is common? 3x is common, x plus 4 is left, and from the second group you have minus 1 common, you left with x plus 4 equal to 0. So make sure you get the same bracket, x plus 4 like this. X plus 4 is common, so you left with 3x minus 1 equals to 0. So after that, you put each of them equal to 0. You will get x equal to minus 4, and here you will get 1 over 3. Okay, so Benjamin got the answer there, 1 over 3 and minus 4. Okay, so this is the idea behind this, and you can use this method for solving any quadratic equation. So important step is you need to multiply 4 with 3, which is the coefficient of x square. Okay, if you don't have any coefficient, then it's fine, you will get the same answer back. Let's say if it is x square instead of 3x square, so you will get only minus 4, which you can factorize. Okay, once you are good at factorization, so it's very quick. Okay, so I think from the exam papers you can practice fractions. You can practice fractions. You can practice questions related to factorization. Okay, and equations, solving equations, linear equations basically, and quadratic as well. If you're using any book, then at the back of the chapter you will see revision exercise where you will find a lot of examples related to that. So anybody has any question from anywhere, like from the book or from the based on whatever we did? Anybody prepared any question? Okay, so we got a question there. How do you solve for x in a cubic equation? Okay. So let us take an example. I want to find out, let's say, factors of 2x cubed plus x square minus 13x plus 6. Okay. This is called cubic equation because the power of x is 3, isn't it? The maximum power of x is 3. So that's why it's a cubic equation. Now, you need to get the first factor, okay? And the first factor, you can get it using trial and error method. What is trial and error method? So you choose some random values for x, and if you get 0 after solving this, that means that's the factor. For example, okay, if I choose, let's say 1, in the calculator it would be quicker because you can just change the values and see which one is giving you 0. So this will not give you 0 because this will give you 2 plus 1 minus 13 plus 6, isn't it? So that's definitely not equal to 0. 6 plus 2 is 8, 8 plus 1 is 9, 9 minus 13 is not 0. So that means it's not a factor. Okay, so you need to try some numbers, and generally it should give you answer between 1 minus 3 and 3. Okay, so let us choose, let's say, minus 3. So 2 minus 3 cube plus minus 3 square minus 13 times minus 3 plus 6. So minus 3 cube is minus 27. So this will give you minus 54. This will give you 9, and minus 13 multiplied by 3 will give you 39, and then plus 6. So 39 plus 9 is 48, and 48 plus 6 is 54. So minus 54 plus 54 is equal to 0. So x minus 3, x equal to minus 3 is your first solution, but you need to find out the other solutions. So what you need to do then, you need to write down this as a factor form, x plus 3, like this. Okay, so you got the first solution, and now you need to get the other two solutions, because cubic equation will give you 3 factors. So how to get the other two solutions? So I hope everybody is familiar with long division. So other two factors, you can get it using long division. So how to do long division? 2x cube plus x square minus 13x plus 6. And you need to divide by x plus 3. Okay. So what would you multiply with x to get 2x cubed? So x multiplied by 2x will give you, or 2x square give you 2x cube. Okay, x multiplied by 2x square will give you 2x cube, and whatever you multiply to x, you have to multiply with 3 as well. So 6x square. 3 multiplied by 2x square is 6x square. And what you do then, you subtract. So this is gone. This will give you minus 5x square, and you bring this down, minus 13x, and then you repeat the process again. So x multiplied by minus 5x will give you minus 5x square, and 3 multiplied by minus 5 will give you minus 15x. Then you subtract. So when you subtract, the sign will change. So that's gone. Minus 13 minus 13 plus 15 will give you 2x. And then you bring this 6 down, and then repeat the process. So x multiplied by 2 will give you 2x, plus 3 by 2 is 6. So, and if you subtract, you will get 0. So at the end, you should get 0, otherwise something is wrong in your long division. So the other two factors are presented as a quadratic expression there, 2x squared minus 5x plus 2. So what you need to do then? You need to solve this. 2x squared minus 5x plus 2. Okay, so the idea is 2 multiplied by 2 will give you 4, and factors of 4 is 4 by 1. I want minus 5 in the middle, so minus 4 minus 1. So 2x squared minus 4x minus 1x plus 2, and then 2x is common, x minus 2, minus 1 common, x minus 2, x minus 2 common, 2x minus 1 equals to, let's say, 0. So x minus 2 equal to 0, 2x minus 1 equal to 0. So x equal to 2, and 2x equal to 1, so x equal to 1 over 2. So we got 3 answers. One is x equal to 2, x equal to x equal to half, and the previous one was x equal to minus 3. So in cubic equation, you will get 3 answers like this. Okay. Okay, so I think you can practice these questions which we covered today, and from the book or from the exam papers, and see how you're getting on. And then we'll continue next time for the other remaining questions. Okay. So I'll see you guys next week. Okay. Thank you. Thanks for attending the class. Bye. Thanks.